Welcome to Learning with Philemon. In this video, we will be looking at the properties of simple covalent compounds. Simple covalent compounds are molecules that consist only of a few atoms that are covalently bonded. See the next video to learn about macromolecular or giant covalent structures in which a large number of atoms are covalently bonded together. An example of a simple covalent compound is hydrogen, H2. If we had a microscopic view of a sample of hydrogen gas, we would see hydrogen molecules moving independently from each other. In each H2 molecule, the hydrogen atoms are covalently bonded. This is called an intramolecular force or bond. Intra signifies that it is within the molecule. However, there is no chemical bond between two hydrogen molecules. There is only a weak intermolecular force between them. Inter signifies that it is between molecules. Think of the word international, which means between nations. Below negative 259.2 degrees Celsius, hydrogen is a solid. The atoms are close together and can only vibrate. See the kinetic theory of matter video for more detail on the structure of solids. At this temperature, there is not enough energy to overcome the intermolecular forces and allow the molecules to move past each other. Because these forces are weak, however, there is enough energy to melt hydrogen at negative 259.2 degrees Celsius, at which point hydrogen is in the liquid state. Hydrogen boils at negative 252.9 degrees Celsius. Above this temperature, hydrogen is in a gaseous state, so the hydrogen molecules move rapidly and randomly and are far apart from each other. A common misconception is that during a state change, the covalent bonds are broken. However, it is only the intermolecular forces that are overcome. There is no change in the covalent bonds. Gaseous hydrogen still contains H2 molecules, but they are just further apart. Simple covalent compounds will often be liquids or gases at room temperature. Water is a good everyday example of a simple covalent compound. Water consists of an oxygen atom covalently bonded to two hydrogen atoms. See the covalent bonding video for more on why this is the case. Water is a solid ice below 0 degrees Celsius. At 0 degrees Celsius, ice melts, so at room temperature, 25 degrees Celsius, water is a liquid. At 100 degrees Celsius, water boils, becoming a gas. Water has a much higher melting and boiling point compared to other simple covalent compounds, such as hydrogen. Remember that hydrogen melts at minus 259.2 degrees Celsius. The high melting point and boiling point of water is due to hydrogen bonding, which is covered in the A-level and IB intermolecular forces video. Simple covalent compounds do not conduct electricity or heat in any state. For the conduction of electricity, you need ions or electrons that are free to move. See more in the ionic and metallic bonding videos. In the case of simple covalent compounds, the electrons remain between the oxygen and hydrogen atoms in the covalent bonds. Be wary that this is only true for pure or distilled water. This water is usually found only in laboratories. Tap water, pool water, or seawater contain salts, so they do conduct electricity. If electrical devices or wires without insulation are placed in water, this could lead to serious injury or even death from electric shock to anyone in the water. Finally, when simple covalent compounds are solids, they are soft and brittle. Iodine is also a diatomic molecule consisting of two iodine atoms covalently bonded together. As iodine has a melting point of 113.7 degrees Celsius, it is a solid at room temperature. Check out the IB and A-level intermolecular forces video to find out why iodine is a solid. In this photo from Encyclopedia Britannica, we see that iodine actually looks like a metal, with a gray, shiny color. However, these pieces of iodine will break easily when a small pressure is applied, hence the term brittle. In conclusion, simple covalent compounds are molecules that consist only of a few atoms that are covalently bonded. They have low melting and boiling points, are usually liquids or gases at room temperature, they do not conduct electricity, and are soft and brittle. I hope that you have found this video informative. If you haven't already, please subscribe for more content. Stay curious.